I'm Associate Professor in Cognitive and Learning Sciences and Computer Science. My lab is Mind, Music, Machine Lab. And I'm also directing the Center for Human-Centered Computing. My research areas include 4 different A's. Auditory displays, so we do sound design and sonification. Sonification means translating all the data into auditory dimensions. And we do auto UI. So we're working on driving research with government, industrial partners, and other universities. We have a bunch of that. That's the focus of today's talk. Affective computing. So in addition to people's cognition and behavior, we take into account emotions and affect to the equation. And we do assistive technologies. That's the whole goal, right? We want to help people with technologies. What type of people? Especially those who have some difficulties and disabilities. For example, blind people, kids with autism, and old adults. So mostly we doing driving research using our driving simulators. Largely we have 3 types of simulators, so it's all standardized, and one simulator we have scenario writable. And one of the strengths in my lab is we using all kinds of sensors, including behavioral, neural, and physiological. So for example, we have eye gaze, facial expression detection, we have ECG, EMG, and fMRIs, very similar to fMRI. And simultaneously, all the driving data saved automatically to our driving server. So we include all that data. As you see these graphs, as a function of hazards or whatever driving events, we can reliably estimate drivers' emotional or affective states and then predict their performance. So after we estimating or detecting their states, what we're going to do? We're going to intervene with them, with technologies, right? So we design auditory displays, warnings, and traditional speech dialogue. But nowadays, more alerts for takeover in automated vehicles. And we do design real-time sonification. So, for example, all the physiological sensing data, it's all numbers. And driving performance, speed, and lane deviation, these are all numbers. So we translate those numbers into musical parameters and then generate some sound. So while you're driving, you listen to soundscape, how you drive. So that reflects your driving and also can guide how you're supposed to drive. And nowadays, we're doing more gesture interaction in the vehicle. The one interesting thing we found is only when sound or auditory displays added to your gesture, that improves driving performance and secondary task performance. So finally, nowadays we're doing more and more collaborative driving research by combining multiple driving simulators. So why do we do that? Because we want to help out people with difficulties and disabilities who used to be excluded from transportation. So with automation, we can do inclusive design. So let's say in automated vehicle scenarios, platooning or car following, if they can communicate or interact with other cars, right, then that'll be easier and very helpful for them. And nowadays, we're looking at the interactions with outside the vehicle, not just drivers. So for example, pedestrians, NHTSA has a new guidelines, so all hybrid vehicles have to generate sound for blind people and old adults. So Google has a patent, visual display, hey, good to go. But we want to dig into auditory displays, how to interact with pedestrians. Thank you.